in case. So because the motor currents play a vital role, because directly, if I didn't choose the starting current or the running current, while what will happen is directly proportional to the losses, because the copper loss is nothing but I squared R losses. So copper loss is directly proportional to square of the current. So we have to maintaining the motor current in the permissible limit. So current play a vital role in the selection of power rating. The next one, torque. Torque is nothing but again it's a function of flux and current. If I'm choosing a constant flux type, my current is directly proportional to the torque. So therefore, the motor current is depends upon the magnitude of the load as well as loss produced by this current. So due to the losses, the heat produces inside the motor. So amount of heat produced depends upon the magnitude and duration of the load current. I'm repeating once again. So before I said temperature rise is directly proportional to the output power. If my temperature is increasing or decreasing, it will be affecting on the output power. Before that, the temperature will be increasing due to the losses. The loss is directly proportional to the square current or less than current or equal current. So all we have to talk about the first initially the current. So the current play a vital role for all the things. So we have to consider the amount of heat produced is depends upon the magnitude as well as magnitude of the load is always directly proportional to the current. So I'm repeating once again, depends upon the current, my losses will occur. Due to the losses, heat will be generated. Due to the heat, what will happen? My output power will be affected. So this is a direct relationship. So everything we have to see in terms of current as well as torque and then speed. Then only I can control the output power of my motor, because my output power is directly proportional to the multiplication of torque into the speed. Torque is nothing but is directly proportional to flux into current. So if I'm choosing a constant flux, my torque is directly proportional to the current. So everything we have to talk about in terms of current. Yes? Any doubt? Any doubt in it? I didn't go into the power rating of motor. I just saying the basics of the selection of power rating. If you understood only, then only I can move into the continuous duty and constant load.
Ma'am, yes, ma'am, understood.
Yes?
Yes, ma'am.
Yes. So what will happen? Again, the thermal overloading will come this next point. Again, the temperature will be increasing over the ambient value. The heat will be produced at the surrounding medium. So whenever when the equilibrium condition occur, my heat dissipated equal to heat generated. The time the steady state temperature will be occurred. So the temperature must not be more than the permissible value. If my temperature will be increasing above the permissible value, what will happen? My insulating material will be get damaged. So in order to avoid that, we have to choose the proper insulating material. There in your textbook they have given the insulating material type ISS 1271. So this is the proper insulating material. Is nothing but the ISS code of the insulating material. This type of insulating, it can withstand the permissible value. So there they have used for the insulating material. Another one insulating material is that according to the ISS 4722, there only we have talked about the 8 classes of duty. The last class I have discussed about the continuous duty and short time duty and intermittent duty. That you have to consider the ISS 4722 insulating material. If you are going to choose the insulating material, then you have to select the power rating of the motor depends upon the continuous duty and then short term duty and intermittent duty, because depends upon the load only, I'm going to select a power rating. I'm repeating once again why I'm saying this load and then output and all. And the selection of power rating is directly proportional to the load. So based on our load, then only I can choose the power rating. Sometimes, now I'm coming to the types: continuous duty and constant load. If it is constant load, there is no problem in selection of power rating. I can easily select a power rating of motor, because constant load, while my drive is running continuous duty and constant load, what will happen? There is no temperature rises will occur. So what will happen? I can easily select a power rating of motor. Have you all got my point? Until now, any doubt? Have you all? Now somebody unmute and say, have you all got my point? The continuous duty and constant load. Now somebody unmute and say.
Ma'am, please repeat, ma'am.
புரியுது என்ன சொன்ன ஹர்ஷவர்தன்?
மேம் இன்னொரு டைம் கொஞ்சம் மெதுவா சொல்லுங்க மேம்.
I'm teaching very fastly.
நீங்க பேசுறது ரொம்ப ஸ்பீடா இருக்கு மேம்.
ஸ்பீடா இருக்கா? Okay, okay. And then I'll reduce my flow. Have you all understood the insulating material? ஹர்ஷவர்தன்?
எஸ் மேம்.
இந்த கிளாஸ் ஃபுல்லுமே நான் ஃபாஸ்டா போயிட்டேனா இல்ல மறுபடியும் திருப்பி ரிப்பீட் பண்ணணுமா?
இல்ல இது மட்டும் சொல்லுங்க மேம்.
Okay.
Continuous duty and constant load.
Continuous duty and constant load is nothing but already the before point I said, the depends upon the load, I can choose the power rating of motor. They have for selecting a motor, they didn't give any power rating and then voltage values. For the load requirements only, I can choose the power rating of motor. So in some cases my drive will be run at a constant load, and then in some cases
ஓரியன் பாடி ஷாப் சொல்லணுமா ஃபோன் பண்ணி கால் பண்ணி சொல்லணுமா?
in some cases my load will be varying. So for continuous duty and constant load,
mail id
ஹர்ஷவர்தன் அன்மியூட் பண்ணுங்க.
மியூட் பண்ணிக்குங்க.
மியூட் பண்ணிக்கங்க.
So constant load, there is no problem of selecting my power rating. If it is constant load, my temperature will be maintaining at the steady state value. So for continuous duty and constant load, I can easily choose the power rating of motor. Yes, but in variable load, my load will be varying. So depends upon the load, and temperature will be varying. So while temperature will be increasing, there is a difficulty to find out the power rating of motor. So normally, that's why they have chosen for the continuous duty and constant load. So next slide. So this is where I can find out my power rating. If my drive is continuous duty and constant load, I can easily find out the power rating with the help of this formula: P is equal to T omega by 1000 kilowatts. So there I can easily find out my power, because it is constant load. So what will happen? My torque will be constant, my speed will be constant. From this I can easily find out my power. Since some textbook they have given P is equal to NT by 975 efficiency, that is also correct. It will be differing. The power value, power formula will be varying in two textbooks. You can write anything. Our main aim, we should write for continuous duty and constant load, the power selection will be very easy. You have to write the formula. That's all about the continuous duty and constant load. The next one, continuous duty and variable load. There we have to find difficulty to find out the power rating, because if my temperature will be varying, once it will be varying the maximum permissible value, what will happen? there is a breakdown of insulation will occur, and then there is a fault occur in this motor or whole setup of drive. So there we have to run my machine with the permissible value or ambient value. If it reaches the above value, what will happen? There is a fault will occur. So while selecting a continuous duty and variable load, we have to go with the several types. So we cannot consider only the temperature and then current. There is a 4 methods is there to find out my power. In some cases, my current will be varying. I'm going to find out my I equivalent. If my torque will be varying, I'm going to find out my torque equivalent there, because I'm keep on varying my load, my torque and current, and then temperature will be keep on varying. So we have to select my power rating with the help of the analytical study. So I have to run my motor for overload and then no load. So there I can find out the temperature rise and then torque rise. So for one load, it will be, I take it as T1 or I1. I am going to run it as another load. So I have to note it on the temperature value, and then current value is T2. So it depends upon the analytical study. I can find out the power rating of motor, because in some cases they have given only the drive. They won't mention about the capacity or power rating of motor. There I can find out the power rating with help of the load only. So for variable load, I have to run my load for no load to full load. There I have to take it out the values of current and temperature. There I have to check with the formulas. I can, if it is okay, then I can stop and then I take it as the equivalent value. Other, if it is not satisfied, if it is not get the proper value, I have to run again for my variable load. Then I can find out the power rating. So again, it is very difficult to select the motor capacity through the analysis of load diagram. So this is not accuracy method. So moreover, while selecting a motor or while selecting a drive, we have to go with the constant load only. If it is variable load, we have to further we have to move with the another function, because I already said the temperature will be increasing. So what will happen? We cannot find out the power rating of the motor. I have go with the analytical study, and then I can repeating once again to get the proper value or exact value of the power. Till that, I need to go with, I have to run the machine again once again. So until I get the exact value of power. This is the fault occur in the continuous duty and variable load. This is the last 2 point I have set in the analytical study and then the accuracy of this method. Is it clear? Continuous duty and variable load. Is it clear? This is the basics of continuous duty, and then I didn't go deep inside. If you understood, and then only I can move to the next one, because there is another step, another method, how I'm going to find out the analytical study of heating. There is a four types is there in the continuous duty and variable load. So this is the continuous duty variable load. Commonly is divided into 4 types: methods of average losses, an equivalent current method, an equivalent torque method, and equivalent power method. See why I am moving to the types, because already said, if it is variable load, I cannot find out the power rating. So there I have to go with the analytical study of heating, because variable load, you have to choose the proper power rating. We have to check the for overloading and no load conditions. You have to find out the current value and then torque value and then average losses. There you can find out the power rating of motor. So the first one is method of average losses. So what will happen? I'm going to run my machine for full load to no load. There I can note it down the step by step. I have to note it down that average loss. That means losses value. Q is nothing but losses occur in the motor. So for first load, if I'm giving a 1/3 of load, I have take it as is Q1. If I'm increasing another load, what will happen? The next step, I'm going to find out the average losses. I have named as Q2, and then I'm going to run the half of the load. There I can find out the Q3. So from no load to full load, I'm going to run my drive. There I can note it on the temperature or losses value. From this value, I can find out the Q average. So based on the average of losses, I can easily find out my power rating. So there is another formula to find out the power with the help of the losses. P is equal to QH by 102 efficiency. So you can find out power rating with the help of the average losses as well as current and torque. And then there's another method is called equivalent power method. So already said, power output power is nothing but product of speed and then torque. So there I can easily find out the equivalent torque method. Because I can find out the equivalent torque, I can easily find out the power value, because there is so many formulas to find out the power in terms of drives. So the first method is method of our average losses. There I have said P is equal to QH by 102 efficiency. There I can substitute my Q average value. There finally I can find out my the rated power rating of my motor. So this is applicable for all the another method. The next one is methods of current, equivalent of current method. Again, for next slide. Again, I'm going to drive my motor from no load to full load. Every step I have to note it down the my current value. For T1 is nothing but particular time. How I'm going to, you have to select, you have to note it down the time period. How much, how minute or hours, how many seconds it will be run for the particular load. 1/3 load or 1/2 load, and then half of the load. We have to take it down from the time also. So there I can find out the I equivalent. So I equivalent formula is nothing but square root of I1 square T1 plus I2 square by T2 and I3 square T3, and then up to n. How many times you are going to run? So depends upon the value, it will be varying. So there I can find out the I equivalent. So what is the formula? Power is nothing but T into omega. T is nothing but directly proportional to I into pi. So there I can find out my torque value. There I can substitute my torque value. So for the another formula is nothing but power is equal to voltage into current. So there I can substitute my I equivalent. So from this I can find out my power rating of my machine. Any doubt? So the graph is nothing but already said, no load to full load, I'm going to drive the motor. There I can find out my I1 value and I2 value. So if I drawing the graph with respect to I1 and T1, so the graph will be like this. Any doubt in it? Any doubt? Shall I move to the next one? Have you all copied the formula and then graph? Somebody unmute and say.
Yes, sir.
We all understood. Okay, copy பண்ணிக்கலாம். And do you have any doubt? Please ask now itself. Yes. Shall I move to the next one? Have you all copied the diagram? Yes. The next one is equivalent torque method. The same. Again, I'm going to drive my drive from no load to full load. There I can find out my step-by-step value of torque, and then with respect to time. There I can find out my T equivalent. Again, the same formula. Instead of I1, I have changed it as T1. It is same as the previous one. The same formula I simply replaced with the torque value. So T equivalent equal to square root of T1 squared and T1 and T2 squared T2, and then up to Tn squared Tn. Again, the same procedure which I said before. You have to drive the motor from no load to full load. There you can find out the values for step by step T1 and T2 with respect to time. From this you can find out the T equivalent. We know that P is equal to T omega by 1000. There you can substitute the values. From this I can find out the power rating of my motor. Yes. Any doubt in it? Equivalent torque method? Any doubt? Yes, the next one. So equivalent power method. Power is directly proportional to torque. Again, I'm going to run my machine with a various speed. So there I can find out my power. So P equivalent equal to P1 squared into T1, and then P2 squared and T2. The same formula I simply replaced with the T instead of P. So this is the another method. You can find out the equivalent power. Our main aim to find out the power rating. So for variable load, so there you have to run the machine from no load to full load. There you can note it down the step-by-step value of torque, and then speed, torque, current, and then losses as well as power. From this you can find out the equivalent value of power and torque and current. And then finally I'm going to substitute my power formula, and then finally I can find out the power rating of motor. So this is applicable for only the continuous duty and then variable load. For continuous duty and continuous load, there is no problem. We can easily find out the power rating with help of the formula, because there my current torque and speed will be constant. Because if it is constant load, there is no temperature rises, my torque will be constant, my speed will be constant. So that I can easily find out the power rating of my motor. If it is variable load, then only it will be difficult to find out. We have to find out the analytical method. So because if I find out my value, for example, so go to the equivalent current method. So if I find out the my I max and I minimum, if it is less than 2 or 2.5, what will happen? If it is greater than R3, for example, how I am saying is the I minimum, which is I minimum in this equation, I equivalent. Have you all? Now there I can, there is a formula, I equivalent to I1 squared into T1, yes or no? So where I can say which is I minimum in this equation. I say, I think and say which is I minimum and which is my I maximum. in this equation. Now, have you all got my point? What I'm saying? Now, how can I say which is I minimum and I maximum? How can you find out I minimum? Now, somebody unmute and say
102. Abhinas. Answer the ma'am question.
if you're not responding, we will mark it as absent for you. 1 or 2. No one know about I minimum and I maximum. Is it so?
Okay, we mark absent for 1 or 2. It is
Okay, sir.
221. Rahul. Answer the question. What is I maximum and I minimum? Answer is in the slide itself.
Yes, sir.
Can you answer the ma'am's question?
How can you choose I minimum and I maximum? Now, from this equation, you can say what is I minimum and I maximum.
What about Rahul? Did he know?
Yes, sir. Yes, sir.
103, Ajay.
It's
Can you
very
answer
easy
the question?
Ma'am, that 1.65, that one.
Wrong. பேசிக் கொஸ்டின் கேட்குறேன். நான் வேற எதுவுமே கேட்கல. உன்கிட்ட பேசிக்கா ஒரு கொஸ்டின் கேட்குறேன். அந்த ஈக்குவேஷன்ல இருந்து ஐ மினிமம் எதை சொல்லுவேன், ஐ மேக்ஸிமம் எதை சொல்லுவேன்னு சொன்னேன். அந்த ஈக்குவேஷன் கொடுத்துருக்கிறேன். I1 squared into T1 and I2 squared into T2. Then how I can choose I minimum and I maximum. பேசிக்கா I minimum எப்படி செட் பண்ணுவேன்னு கேட்குறேன். No, you are on the online. We cannot say how you are listening or not. ஃபர்ஸ்ட் மாடியூல நான் முடிக்க போறேன். ஒரு ஐ மினிமம் ஒரு வேல்யூ இதுல இருந்து எப்படி கண்டுபிடிக்கிறதுன்னு கேட்டா நீ இவ்ளோ திணறனா என்ன பண்றது நானு? So who knows the answer? How I can find out the I minimum from this equation? Somebody say. All of you. All of you is there. No one is there. Is it so? No one is know the answer of I minimum and I maximum. Is it so? Somebody unmute and say, do you know or not? No.
Okay, ma'am, we will repeat it.
Starting itself, I said continuous duty and variable load. You have to find out the power rating of motor by analytical study. For analytical study, you have to run the drive from no load to full load. So there you can find out the step-by-step value of I1 and T1, and then if it is current equivalent torque method, you are find out the T value. For first, if I'm running my machine with no load, what will happen? This is the minimum value of current. So I take it as I minimum is no load value of current. Yes. And then in the next step, what will happen? I'm increasing my load. What will happen? My current will be changing. I take it as I2. And then again, furtherly, I'm increasing my load. The current will be varying. So that is the I3 value. The same way, if I'm increasing my load with the help of the so if I keep on increasing my load, finally I have attained a overload. What will happen? There is another way. We cannot again overload the machine. So that's the I maximum value. So no load to full load. So no load value is nothing but I minimum. Overload value is nothing but I maximum value. This is what I asked in the question. See why I am saying this I minimum and I maximum value. So there's another formula. If my I maximum by I minimum value is less than 2 or 2.5, if I didn't get 2 and 2 point value, again I have to run the machine from another step. So once I get the equivalent value, till again you have to run the machine from, again you have to notate the value. Once I get the I maximum to my minimum value is 2 or 2.5, then only I get the exact power rating of my value. If my I max, my I minimum is not equal to 3, not equal to 2 or 2.5, and then my reading will be wrong. Again you have to do once again the loading of motor. So it will be repeating on. Once you get the exact value of I maximum, I minimum, then only I can stop the test. Then only I can find out the equivalent current value. From the equivalent current value, I can find out the power rating of my machine. Is it clear now? Is it clear now? So my voice is audible?
Yes, ma'am.
இதுல என்ன கஷ்டம் இருக்கு? நான் அதான் அப்பவே சொன்னல, என்ன சொன்னேன், வேரியபிள் லோட் அப்படின்னா we cannot find out the power rating. So for this you have to go with the analytical study. There it is divided into 4 types: equivalent current method, equivalent average losses, and then equivalent power method and torque method. So for this we have to run the machine from no load to full load. There I can find out the value of step by step. So that step value, for first step I can take it as I minimum. For the last step I can take it as for I maximum value, or T maximum or T minimum. Are you agree my point?
Yes, ma'am.
So if my I maximum to minimum value will not be equal to or less than or equal to 2 or 2.5, you have to redo the experiment. You have to do again. You have to no load to full. You have to do the loading method. Again, you have to find out the I maximum, I minimum, till I get the value of 2 or 2.5 for induction machine. Then only my equivalent current value will be equal. If my I equivalent is correct, then only I can find out the suitable power rating of my motor. If I choose the wrong value of I equivalent, I cannot choose the proper value of power rating. If I didn't choose the power rating properly, what will happen? My machine will be, what will happen? My drive will be get, what will happen? என்ன ஆகும்? தப்பா choose பண்ணிட்டா என்ன ஆகும்? The drive will get damaged, or we cannot frequently overloading my drive. Some deterioration will occur. So for this you have to choose the proper power rating of motor. Is it okay? It will be varying. It cannot be already. I'm repeating once again. It's a constant. It is not constant load. It is variable load. So load will be varying means my torque value will be varying, current varying, temperature will be varying. It is not same. Once it is variable load, everything is changes. So only I can go with the methods of equivalent current and torque method. If my load is constant, I can easily find out that. So go to the continuous duty constant load slide. So if my drive is constant load, there is no worry about the selection of power rating. I can easily select my power rating with help of the T omega y 1000, because if it is constant load, my torque is constant, my speed is constant, my temperature also constant. So the machine will be run at a steady state temperature value. So I can easily find out the power rating of my motor. If it is variable only, I have to move with the equivalent current method and torque method and power method. Yes, have you all got my point?
Ma'am. Yes, ma'am.
Concept புரிஞ்சுக்கோ. Only one concept that depends upon the load. If you understood the concept, then you can easily understand the EDC subject. ஒரே ஒரு பாயிண்ட் தான் இருக்கும், அந்த ஒரே பாயிண்ட பத்தி தான் பேசிட்டு இருப்போம். From the starting of selection of power rating, I have talked more than 5 or 6 times about the temperature, because if my motor is running, heat will be produced. Due to the heat, temperature will be increasing. Due to the temperature, my power rating will be affecting, or output power will be affecting. So then losses will occur. The loss is directly proportional to the current, square of the current. So if my current, so depends upon the current and the magnitude of the load, my power rating and then temperature will be varying. So load, current, and then temperature, and then losses, and then finally the output power. This is the direct relationship of the thermal overloading. This is what I said in the starting of continuous selection of power rating. Yes. The next one, the last one is short time duty. The last topic of first module. See, what is meant by short time duty? What is meant by short time duty?
மோட்டர் வந்து கொஞ்ச நேரம் தான் ஓடும்.
Yes. The machine will run at a only short time period. So after that, we have completely rest the machine. After sometimes only we can start, or sometimes we cannot start. So for particular time, I can run the machine. So for example, I have set in the mixie. For mixie, we can use it for the short time period only. So the for example of short time duty is called is mixie. So for short time duty, how I'm going to find out my power? So this is the last topic of my module 1. So for short time duty, again, what will happen? The temperature rise will be occurring, because I'm going to run a machine for a particular period. So this is the graph. So what will happen? My temperature will be increasing, and then sir, please sir, mark பண்ணுங்க sir, அப்படியே அந்த curve வச்சு. So this is for temperature rise, and then the dropout is nothing but cooling. So again, for short time duty, you have to consider the, okay, so enough. You have to consider the temperature rise also. Again, here the formula will be varying. So next slide, last slide. So here you have to go with the theta value to theta m value. Is nothing but again, while starting, my theta will be very less, and then once it reaches the peak value theta m, it will be varying. So depends upon the theta to theta m, I can find out the power rating of my short time duty. So the last value is nothing but the ratio of px by r. They have given the last sentence, px by pr is nothing but is directly proportional to the, அதாவது heating of the motor is proportional to the losses occurring in the motor, and then which turn proportional to the square of the current, which means my pm is equal to ph, or square root of ph, or Otherwise, I can say it as Px by Pr. So Pm is nothing but motor power, and then H is nothing but load power. The ratio of Px by Pr, I can find out the short time duty power rating. I'm repeating once again. Short time rating of motor. Here, the electrical motor is subjected to the PR. Is nothing but we can continuously run the motor, and then after time, what will happen for particular period? It will be turned off. So there, you can find out the continuous power rating as well as no load power. There, I can find out the theta to theta m value, because the temperature will be increasing at particular period. After that, it will be come to the rest period. So the last one, with the help of the theta to theta m value, I can find out the equivalent power value. So you have to use the formula theta by theta m. From this, I can find out the ratio of PR by PX. This is the short time duty. Is nothing but PM is nothing but no load, the starting load to full load. At particular period, we have to start the machine. So at 0 period, what is the power value, and then maximum value at theta to theta m. There the equation is wrong. Theta by theta m. So theta is nothing but Px, and then theta m is nothing but PR. So there you can find out the ratio of Px by PR. With the help of the temperature rise, and then no low temperature, I can find out my ratio of Px by PR. Is nothing but theta to theta m value. Is it clear? Is it clear? Okay. So that's all about the module 1. I have covered all the topics. In the last class, I have talked about the selection of motor and then selection of enclosure. These all are not into the syllabus, but even though I have said briefly about how to select the electrical motor and how to select the selection of enclosure and all. Sometimes they make question from this part also. So I have covered all the topics. I think I didn't miss any topic from the module 1. If you have any doubt, please ask now itself. I will recall once again the any doubt? Any doubt?
No, ma'am.
No. இப்போ வரைக்கும் நடத்தினதுல மாடியூல் 1ல உனக்கு இது எந்த டாபிக் புரியவே இல்லை, அதை சொல்ல நான் இப்ப நடத்துறேன். Shall I discuss about the last class MCQ question? I have given so far the 4 MCQ.
Today also we are having one.
Yes,
One MCQ
today also we have one MCQ. If you have
Can
no
you
doubt,
show us the notes till now you have taken in the class
yes,
period?
all of you show the notes one by one. Now, if you have no doubt, we can move with the note side part. Otherwise, I will repeat once again the selection of power rating of motor.
You want to discuss the questions also, ma'am? MCQ
Yes.
question. And also we are having
Yes.
today MCQ.
Yes.
There is any doubt, we will discuss here.
If you have any doubt, see, I will give 2 more minutes. Just recall your notes. Sir, once sir PPT ஒரு வாட்டி ஃபுல்லா போட்டு காமிச்சிருங்க, ஏதாவது டவுட் இருக்கான்னு கேட்டுடலாம். So, see, all of you see each slide. If you have any doubt, say that time itself, then I can teach once again. see the basics of electrical drive. Where Monday will be a revision class of first module. I will recall all the topics. So the next one, sir. So go with sir. If you have any doubt, please start the PPT, and then I will say what is mean and all. So this is the important question: the basic elements of drives. Then advantage of electrical drives. Yes. I will post today the PPT in Google Classroom.
Okay, ma'am.
Choice or selection of electrical drives, and then individual drive, group drive, and multi-motor drive. Any doubt? Comparison of DC and AC drive.
This is also important question.
Yes.
Previous question also important.
Next one. Application. It will come under 2 marks. The factor affecting the selection of drive. Heating and cooling curve. I have given the deep derivation. I have sent the PDF also. And then load condition in motor, speed control and torque control, and then classification of loads and classes of motor duties are another important question. Class of motor duty. And then selection of electrical motors. This is not your syllabus, but I have taught on the selection of enclosures. And the last topic is selection of power rating of motor. Till now, any doubt? If you have any doubt, all of you understood. So you can all get 100 marks in EDC in internal one. Is it so? Yes. So around 96 members is there in your class. So I want 100 from all of you because you said you have no doubts. Yes. You said no doubt. So I expect 100 marks from all of you. Is it clear? நீ 100 மார்க்ஸ் எடுக்கல அப்படின்னா எனக்கு நீ ப்ராப்பரா ரீசன் சொல்லணும். ஏன்னா உனக்கு இப்ப டவுட்டே இல்ல.
We will ask questions, ma'am. 107 Chandru. Can you tell the formula for the equivalent current method? How to find the equivalent current method? We start in the today's class. Chandru.
One not 7. Are you there?
I think she gone. No, ma'am. Chandru, can you unmute and answer the question? RLE post.
Not working.
What is not working? Mic. Okay, chat in the question. Not able to chat in the question. Google.
Ma'am.
Yes.
Okay.
Ma'am, continuous duty motor short duty motor different.
புரியல என்ன கேக்குறான்? Say louder.
Ma'am, continuous duty motor short
Continuous duty means I'm going to drive the motor without any stop.
தமிழ்
கண்டினியூஸா என்னோட மோட்டார் டிரைவர் ரன் பண்ணிட்டே இருப்பேன். நான் ஸ்டாப் பண்ணவே மாட்டேன். கண்டினியூஸா ரன் ஆயிட்டே இருக்கும். ஷார்ட் டைம் டியூட்டி அப்படின்னா ஒரு பர்டிகுலர் பீரியட் மட்டும் நான் ஸ்டார்ட் பண்ணுவேன் என்னோட மெஷின் ஆர் என்னோட டிரைவர். ஃபார் எக்ஸாம்பிள் மிக்சி சொன்னேன். மிக்சி எப்பவுமே நம்ம வீட்டில் ஓடாது, எனக்காக தேவைன்னா மட்டும் யூஸ் பண்ணுவோம். அதான் ஷார்ட் டைம் டியூட்டி. கண்டினியூஸ் டியூட்டினா ஃபேன் மாதிரி. ஃபேன் எப்பவுமே நம்ம வீட்டில் ஓடிட்டே இருக்கும். அது எப்பாவது ஒரு 2 நிமிஷம் தான் ரெஸ்ட் கொடுப்போம். ஆனால் நீ பார்த்த அப்படின்னா எப்பவுமே வீட்டில் ஃபேன் எல்லாம் இருக்கவே இருக்காது. எங்கே போனாலுமே கரெக்டாக நைட்டும் சரி சரி பகலாலும் சரி கண்டினியூஸாக ரன் ஆகிட்டே இருக்கும். ஸோ இதுதான் கண்டினியூஸ் டியூட்டி.
இப்போ ஷார்ட் டைம் டியூட்டி மோட்டரை வந்து நம்ம ரொம்ப லாங் டைமா இது பண்ணா
புரியல.
ஷார்ட் டைம் மோட்டர்
சத்தமா பேசுறதுக்கு ஒன்றும் கேட்கல.
ஷார்ட் டைம் மோட்டர்
ஷார்ட் டைம் மோட்டர் இந்த ஷார்ட் டைம் மோட்டர் வந்து லாங் டைமா போட்டா என்ன
கிளியரா இல்லடா.
ஒண்ணுமே புரியல. சார் சம்படி சேட் இந்த மாதிரி தமிழ்ல டீச் பண்ணா சூப்பரா இருக்குங்கறான். we cannot தமிழ்.
இப்போ கேக்குதா மேம்?
எஸ்.
சொல்லுங்க.
ஷார்ட் டைம் மோட்டர் வந்து லாங் டைமா ஓடினா ஏன் மிஷின் ரொம்ப டேமேஜ் ஆகுது?
ஷார்ட் டைம் டியூட்டியை லாங் டைமா ரன் பண்ணினா மிஷின் ஏன் டேமேஜ் ஆகுதுன்னு கேக்குறியா?
ஆமா மேம். அதுக்கு என்ன காரணம் மேம்?
இல்ல இப்போ நீ ஷார்ட் டைம் டியூட்டிக்கு அதான் என்ன சொன்னேன், ஃபார் ஷார்ட் டைம் ஆர் லாங் டைம் டியூட்டி நீ என்ன உன்னோட லோட் ரெக்கமெண்ட்ஸ் பொறுத்து தான் என்னோட பவர் ரேட்டிங் சூஸ் பண்ணுவேன்னு சொன்னேன். இப்போ நீ வந்து என்னோட டிரைவர் ஷார்ட் டைம் டியூட்டிக்கு மட்டும்தான் ரன் பண்ற அப்படின்னா என்னோட பவர் வேல்யூ சேஞ்ச் ஆகும். அதே கண்டினியூஸா ரன் பண்ற அப்படின்னா என்னோட பவர் வேல்யூ சேஞ்ச் ஆகும். எப்படி நீ ஷார்ட் டைம் டியூட்டில இருக்கிற மெஷினை கண்டினியூஸ் டியூட்டி யூஸ் பண்ணுவேன்? the power rating will be varying.
டிசைன் கன்சிடரேஷன்லயும் மாறும்.
டிசைன் அதுக்கு தான் சொல்றேன். அந்த செலக்ஷன் ஆஃப் பவர் ரேட்டிங் அதுக்கு தான் கொடுத்துருக்காங்க. ஷார்ட் டைம்க்கு நீ யூஸ் பண்ற மோட்டரோட பவர் ரேட்டிங் டிஃபரெண்டா இருக்கும். கண்டினியூஸா யூஸ் பண்ற என்னோட டிரைவுக்கு என்னோட பவர் ரேட்டிங் வேரியா இருக்கும். அதுக்கு தான் வந்துட்டு நான் சொன்னேன் வேரியபிள் லோட் அப்படின்னா பவர் ரேட்டிங் கண்டுபிடிக்கிறது கஷ்டம். அதுக்காக என்ன பண்ணுவோம், ஈக்குவலன்ட் கரண்ட் மெத்தடு ஈக்குவலன்ட் டார்க் மெத்தடுக்கு போறோம் அப்படின்ட்டு. நீ ஷார்ட் டைம் டியூட்டில இருக்கிற மெஷினை கண்டினியூஸ் டியூட்டிக்கு ஒர்க் பண்ணலாம். ஆனா பவர் வந்துட்டு மெயின் என்ன சொல்லியிருக்கேன், பவர் வந்து மீட் அவுட் ஆகல, சேமா இல்ல, கண்டினியூஸ் டியூட்டில ரன் பண்ணும்போது என்ன ஆகும் அப்படின்னா பவர் வந்து ஃபெயிலியரா தப்பா சூஸ் பண்ணிட்ட அப்படின்னா யூ கேனாட் ஓவர்லோட் பண்ண முடியாது உன்னால. the machine will get damage. அதுக்கு தான் இந்த டாபிக்கே முக்கியமா போறோம். இந்த செலக்ஷன் ஆஃப் பவர் ரேட்டிங் வந்துட்டு ஏன் போறோம் அப்படின்னா இதனால தான்.
So guys, moreover, while we were doing our lab sessions, we will came to know how the load எல்லாம் எப்படி டிஃபர் ஆகுது எல்லாமே வந்து உங்களுக்கு தெரியும். From no load to full load condition, we are taking the readings. Okay, from that we are going to find the power. We are going to find the speed, torque, like that. From if you do only one experiment, you will clearly know what is this. Okay.
Yes. Any doubt in it?
அதான் தம்பி, இப்போ வந்துட்டு நீங்க வந்துட்டு ஒரு எக்ஸ்பெரிமெண்ட் பண்ணோம் அப்படின்னா ஸோ இது எல்லாத்துக்குமே உங்களுக்கு வந்து ஆன்சர் கிடைக்கும். ஓகேவா? நெக்ஸ்ட் வீக்ல இருந்து நம்ம எக்ஸ்பெரிமெண்ட்ஸ் பண்ணுவோம். ஸோ ஃப்ரம் தட் யூ வில் கெட் அ கிளியர் ஐடியா. ஓகேவா?
Have you all understood what is my continuous duty and short time duty?
மேம் மோட்டார் வந்து ஓவர்லோட் ஆகிறதுக்கு காரணம் ஹீட் மட்டும்தானா மேம்? ஐ மீன் அது ரன் ஆகிறதுனால அதுல இருந்து எமிட் ஆகிற ஹீட் மட்டும்தான் அது ஓவர்லோட் ஆக காரணம்.
I have talked about the thermal overloading. There is another one is called overloading is normally if the capacity of the motor is for example என்னோட capacity இவ்வளோ தான் அப்படின்னா you have to load up to that capacity only. If you are loading overloading means there is a problem will occur. So I already said, I have said the thermal overloading. Do not confuse with thermal overloading and normal overloading. Thermal overloading will occur only whenever my temperature will run at above ambient temperature. Then only the thermal overloading will occur. But normally overloading will occur once I have overloaded above the capacity of the machine. So that is called overloading.
ஓகே மேம். மேம் இப்போ நம்ம தெர்மல் ஓவர்லோடிங்கை கண்ட்ரோல் பண்ணலாம்ல மேம்?
Yes,
அது
control
ஒரு
பண்ணலாம். அதுக்காக தானே.
கூலிங்
Yes,
ப்ராசஸ் வச்சு.
yes, you can control. Then only the basic elements of electrical drive there have set the controller part, control unit. There you can write the coding to control the temperature, and then we need a special setup to cooling the machine. So then only there also you can cool the machine.
ஓகே மேம்.
Yes, any doubt?
No.
மேம்
Yes.
இப்போ வந்து ஒரு இடத்துல வந்து ஷார்ட் டைம் டியூட்டி தேவைப்படுது அப்படின்னா மேம், அந்த இடத்துல நம்ம கண்டினியூஸ் டியூட்டி மோட்டரை வச்சு நம்ம ஷார்ட் டைம்ல
Yes, continuous duty can run at a short time duty also, because the continuous duty power rating will be large compared to short time duty. But short time duty is very less because we have going to run for particular period. So compared to continuous duty, short time duty power rating will be very less. But continuous duty power rating we can run as short time duty also. There is no problem.
ஓகே மேம்.
Okay, and then
மேம் அதுக்கப்புறம் மேம் இப்போ வந்து மோட்டார் வந்து அதிகமாக ஹீட் ஆகுதுல்ல மேம்,
yes.
அதுக்கு வந்து இப்போ பைக்ஸ்லாம் இப்போ லிக்விட் கூலிங், அதுக்கப்புறம் இந்த கார்ஸ்லாம் ரேடியேட்டர்லாம் யூஸ் பண்ணுறாங்க.
வாய்ஸ் பிரேக் ஆகுது.
மோட்டரில் இருக்கிறது
சேக்ல இன்னொருட்டி சொல்லு.
Radiator.
மேம் இப்போ வந்து மோட்டர் வந்து ஹீட் ஆகும்ல மேம், நிறைய கண்டினியூஸாக ரன் ஆகிட்டு இருந்தா.
எஸ்.
அதனால வந்து நம்ம வந்து மோட்டருக்கு வந்து ரெஸ்ட் கொடுப்போம்ல மேம், அந்த மாதிரி ரெஸ்ட் கொடுக்கறதுக்கு பதிலாக நம்ம வந்து கார்ல யூஸ் பண்ற மாதிரி ரேடியேட்டர், அப்புறம் பைக்ல யூஸ் பண்ற மாதிரி லிக்விட் கூல்டு இன்ஜின், அந்த மாதிரி லிக்விட் கூல்ட் எல்லாம் வச்சு நம்ம மோட்டர் வந்து கூல் பண்ணலாம் மேம்.
எஸ், பண்ணிக்கலாம்.
அந்த மாதிரி பண்ண மாட்டேன்றாங்க.
பண்ணுறாங்க டிரைவ். I set up the cooling curve. In some cases, now I already set the type of enclosure. Yes. The last class I have talked about the type of enclosure. There we can fit for some cooling purpose. I already set the I think totally enclosed type. In totally enclosed type, there I set the cooling purpose fans. In order to cool off my machine, I can do some special arrangements. So you can use some special arrangement to cool off my machine also. In totally enclosed type, they have some special arrangement. They have some fans to cool off my machine or drive. அப்படியும் பண்ணலாம். புரியுதா?
நம்ம பெரிய பெரிய இண்டஸ்ட்ரி எல்லாம் பாத்தீங்கன்னு வச்சுக்கோங்களேன், ஒரு ஆப்ரேட் ஆயிட்டுன்னு வச்சுக்கோங்க, ஒரு பெரிய மோட்டர் ஆப்ரேட் ஆயிட்டு இல்ல ஒரு ஆல்டர்னேட்டர் ஆப்ரேட் ஆயிட்டு பின்னாடியே பாத்தீங்க அப்படின்னா ஒரு பெரிய கூலிங் ஃபேன் வச்சிருப்பாங்க. இட் மே பி கப்புள்ட் வித் தி மோட்டார் டைப் ஆர்எல்ஸ் எக்ஸ்டர்னலா வச்சிருப்பாங்க. ஓகேவா? எதுக்குன்னு பாத்தீங்கன்னா அதுல ப்ரொடியூஸ் ஆகிற ஹீட்டை வந்துட்டு கம்மி பண்றதுக்கு. ஃபார் எக்ஸாம்பிள் உங்களோட இந்த மோட்டர், நம்ம வீட்டுல இருக்கிற மோட்டர்லாம் எடுத்துக்கோங்களேன். யாராவது போய் மோட்டர் பார்த்தீங்க அப்படின்னா உங்களோட மோட்டரோட ஷாஃப்ட்டுக்கு பேக் சைடு ஒரு ஃபேன் மாதிரி வச்சிருப்பாங்க. எதுக்குன்னு பார்த்தீங்க அப்படின்னா உள்ள வைண்டிங்ல ப்ரொடியூஸ் ஆகுற ஹீட்டை வெளியே தள்ளி விடுறதுக்காக. நீங்க போய் உங்க வீட்டுல இருக்கிற மோட்டரையும் கூட ஒரு எக்ஸாம்பிளா பாருங்க. அது ஒரு எக்ஸாம்பிள் ஃபார் ஃபேன் டைப் மோட்டர். Clear? That is the one cooling method. One type of cooling method.
So normally the temperature will be reduced with the help of the silicon steel. Already said, due to the losses, the temperature will be increasing. So in order to eliminate the losses, we have made up for the silicon steel and then laminated structures. There I can reduce my eddy current loss and hysteresis loss. If my loss is less, my temperature will be very less. So while selecting a construction material, they have chosen for reducing the losses. So for silicon steel and then laminated core, they can reduce the eddy current loss and hysteresis loss. This is the one way to reduce the temperature. While making itself, they have chosen for the silicon steel in order to reduce the hysteresis loss. And then the same way, all the generator and motor will be laminated core, because if it is laminated core, my eddy current loss will be less. Eddy means waste. Waste current will always produce the heating of winding. In order to reduce the eddy current loss, we have used the core in the laminated structures. If you open any motor and generator, the core winding, the armature or field winding will be in laminated, because we need to reduce the eddy current losses. Now to reduce the heating, they have given the laminated structure. So while the designing itself, they have a proper winding or proper structure to reduce the temperature. Yes, this is I setting the basic laws of the generator and motor. Any doubt? Have you all attending the MCQ? Any doubt? Some of them asking good questions. Others?
வேற ஏதாவது டவுட் இருக்கா?
Ma'am, we cannot teach in Tamil. So you need a communication skill. Tamil yaar vena pesalama. You are an engineer.
டவுட் இருந்துச்சுன்னா கேளுங்க.
Yes.
மேம் நீங்க ரெண்டு டைம் நீங்க இங்கிலீஷ்ல நடத்துறதுக்கு ஒரு டைம்ல இங்கிலீஷ்ல நடத்திட்டு இன்னொரு டைம்ல தமிழ்ல நடத்தினா எங்களுக்கு புரிஞ்ச மாதிரி இருக்கும்.
உனக்கு தமிழ்ல வேணும் அப்படின்னா எனக்கு தனியா ஃபோன் பண்ணு, நான் தமிழ்ல ஃபுல்லா சொல்லி தரேன். In class I cannot teach in Tamil. Okay? If you want Tamil means you have to call separately. Maybe afternoon you can call, I will teach in Tamil. But in class I will say only in English. So you are an engineer. You are not child to teach in Tamil. Any doubt? Others? Sanjay 325, any doubt? Any doubt, Sanjay? Others? Okay.
Yes. MCQ லிங்க்
Yes,
போஸ்ட்
sir.
பண்ணிருக்கீங்க. ஸோ எல்லாரும் அட்டன் பண்ணிருங்க.
Have you all attending the MCQ? If you have any doubt, you can call me at any time. So Monday will be a revision class. Please prepare the module 1. I will make some questions to all of you. So please go through the module 1. And then the 2 more problems there regarding short time duty, and then I will teach tomorrow. 3 or 4 problems is there. I will teach on Monday, and then I will discuss about the module 1. and then I will make some question answers. So please prepare for the Monday. And then while going to the lab, you can understand the variation of loads and then how it will be affecting and all. So from Monday onwards, the lab will be going to run. So I will teach, with the help of the virtual lab, I will teach how the load will be affecting on the speed and torque and all.
Guys, don't leave. I'm taking attendance.
So around 83 only there, sir, including us.
I'm taking and note it down, ma'am.
Okay, sir. Okay, sir. If you completed, you can ask question doubt now. Regarding MCQ and then regarding subject, you can ask now. I will be there to help you. Have you all completed? Yes. Somebody unmute and say, have you all completed? Suresh sir, shall we wind up? So it's
Yes,
11
ma'am.
o'clock. So thank you. So Monday,
Thank you,
please
guys.
prepare the first module. I will make some question. All of you, please note it down. Prepare for Monday.
Only 5 were responded for the MCQs.
5.
Remaining only, yes, ma'am. Only
We have
5 were
enough
responded.
time, I think so. We have give about 10:50. We itself make it as free. Then why didn't you attend?
We will give another 15 minutes time. So I'll try to attend the questions.
Now only we get link one. So up to 11:50 it will be open. After that it will be closed. If you want attendance, please mark it as the MCQ, and then please prepare for the Monday class. Thank you. So
Thank you, ma'am. Thank you.
shall we wind up? Thank you, sir.
Thank you, guys. Thank you.